function. So our essential question is, how can I graph linear functions using a table? Vocabulary, linear equation, an equation that creates a line. It creates a nice straight line. If you look at linear, the word line is in the word linear. So that's a reminder that a linear equation creates a line. Function form, an equation in the form of y equals or f of x equals. Graphing equations. First step is to solve the equation for y. Put it into function form. Make it y equals. Second step is to make a table. Third step is to plot the points and connect the points. So let's go through this example. Graph x plus y equals 4. First step, we need to solve it for y. Make it y equals. Move the x. This is what we did at the very end of chapter 3, and this is why we did it, so that we're prepared to rewrite this equation in y equals forms. Now we have y equals 4 minus x. So in our table, I'm going to put 4 minus x after y equals. For my x values, we're going to always use 0, 1, and 2. 0, 1, 2. Put 0 into the function, y equals 4 minus 0. We replace x with 0. 4 minus 0 is 4, so y equals 4. Put 1 into the equation, y equals 4 minus 1. 4 minus 1 is 3. Last one. Put 2 into our equations, we get y equals 4 minus 2, so y equals 2. Now we have coordinate points. We have our ordered pairs. 0, 4. X is 0, y is 4. 1, 3. X is 1, y is 3. And lastly, 2, 2. X is 2, y is 2. We have 3 coordinate points that we can plot on our graph, which leads us to step 3, plotting our points and connecting our points. So first one is 0, 4, which is on our y-axis. Second point is 1, 3, so 1 on our x-axis and 3 on our y-axis. Lastly, 2, 2, so 2 on our x-axis, 2 on our y-axis. And then connect those points. This is a linear equation, so we should get a nice straight line. If we don't get a straight line, it tells us that we did something wrong. Now we have 2 special case lines that are our horizontal lines, so a left and right line, and our vertical lines, straight up and down. So if we want to graph y equals 5, if we look at that, there's no x. In our first equation, we had both an x and a y. In this one, there's no x. So when it's just a y there, no x, y equals 5, that is going to be a horizontal line. Horizontal line. So we're going to go on our y-axis to the point where y equals 5. So right here, y equals 5 on our y-axis. And then we draw a horizontal line through that point. And at every point on that line, y equals 5. X equals something different, but y always equals 5. Now, if we look at our second special case, we have x equals 5. In this equation, there's no y value. There's no y. So when this happens, this is a vertical line. A straight up and down line. And that's going to go through the point x equals 5. So on our x-axis, we find x equals 5. And we draw a vertical line straight up and down through that point. And at that point, x always equals 5. Your y changes, but x always equals 5. graphing a linear function. One last vocabulary word for you. Linear function is a mapping of one input to exactly one output that creates a straight line. So it's putting linear and function, those two definitions together. Our definition for function is a mapping of one input, one x value, to exactly one output, one y value. We talked about that in chapter 1. And we're connecting that to linear, so it makes a nice straight line. Remember linear, that piece of line that's in the word, so it makes a straight line. Evaluating using function notation. So function notation is that f of x equals. For the function, f of x equals 2x minus 10, we want to evaluate it for f of negative 2. So if we look at that, f of x, f of negative 2 is replacing the x. So we're saying we want to evaluate the function when x equals negative 2. So we take our function. We have f of x equals 2x minus 10. And what we're doing is we're replacing x with negative 2. Replace x with negative 2. So we have f of negative 2 equals 2 times negative 2. We put that negative 2 in for x minus 10. F of negative 2 equals 2 times negative 2 is negative 4 minus 10. Keep simplifying it, and we get negative 4 minus 10 equals negative 14. So f of negative 2 is negative 14. This function's value when x equals negative 2 is negative 14. We could write that as a coordinate point, an ordered pair of negative 2, negative 14. We're saying that when x is negative 2, y, or f of x, is negative 14. Remember, f of x is just another way of representing y. Now find x. So now we're looking for x. We want to know what is x such that f of x equals 6. So if we were to replace that f of x with y, we would say y equals 6. So we're replacing f of x with 6. So if we take our equation, f of x equals 2x minus 10, we don't know what x is. We're looking for what x is, but we do know that f of x equals 6. So we can replace f of x with 6. And now we're just solving an equation. We're back to what we did in chapter 3. So undo that addition and subtraction. Add 10 to both sides. We get 16 equals 2x. Undo this multiplication with division. Divide both sides by 2, and we get x equals 8. X equals 8. So we found x so that our function, our equation, equals 6. Last piece is to graph a function with a given domain. So we want to graph the function f of x equals negative 2x minus 7 with a domain of x is less than or equal to 0. Domain means x values, so that means our x values have to be less than 0. Then we want to identify the range. Tell us what the range is. First off, we need to make our table. Fill in our table. X, then we have f of x equals, remember, f of x is the same thing as y. So when we plot our coordinate points, we're going to have our coordinate points of x, y, or x, f of x. So f of x equals negative 2x minus 7. Now remember, our x values have to be less than or equal to 0. So now instead of using 0, 1, and 2, we're going to use 0, negative 1, negative 2. Plug those into our function. We get f of x equals negative 2 times 0 minus 7. Negative 2 times 0 is 0, minus 7 is negative 7. Put negative 1 into our function. We get f of x equals negative 2 times negative 1 minus 7. Negative 2 times negative 1 is positive 2, minus 7 is negative 5. Last point, negative 2, so we put that into our function. F of x equals negative 2 times negative 2 minus 7. Negative 2 times negative 2 is 4, minus 7 gives us negative 3. So now we have our ordered pairs, our coordinate points. We have 0, negative 7, negative 1, negative 5, and negative 2, negative 3. We can plot those on our coordinate grid. 0, negative 7, negative 1, negative 5, and negative 2, negative 3. They make a nice straight line. Now, last piece is we want to identify our range, our y values. So if we look at our y values, we start at negative 7. And are we getting bigger than negative 7 or less than negative 7? If we look, we're getting bigger. As we go to our next x value, the y values get bigger. So we're going to say our y values, or our f of x values, are greater than or equal to negative 7. Those are our y values because we start at negative 7 and we keep getting bigger and bigger for our y values. All right. We're going to move on into an IXL activity. So go ahead and go to the IXL activity posted in Schoology and do that practice, and then you can begin your homework. Thank you for watching this video, and please subscribe to my YouTube channel.